In the previous video, we discovered that all the atoms in the periodic table are made from just three kinds of particles: protons, electrons, and neutrons. The whole world, in fact. Amazing. We know that the heavy protons and neutrons live in the atom's center, called the nucleus. The proton carries a positive electric charge, and the neutron is neutral. The light electrons whiz around the outside of the nucleus and trace out the shape of a fuzzy ball. They carry a negative electric charge. We can show the electrons moving, but it will be easier to keep them still in this video. We can still learn important things about atoms by simplifying the real picture. Let's pretend we have a pile of each of these particles, and then build some atoms from scratch. What's the simplest and lightest atom you can think of? It must be the one with an atomic number of 1. Did I hear you say hydrogen? It makes sense that this atom is made by using just one proton. How many electrons does a hydrogen atom need? Have you noticed that stuff around us is not electrically charged most of the time? You don't go around with your hair standing on end from static electricity. That means that atoms are overall neutral, so that the positive charge of the proton must be exactly cancelled by the negative charge of an electron, and just one electron. The number of protons and electrons must be the same. A hydrogen atom has one proton and one electron. The number of protons equals the number of electrons, and this is true for all atoms. What's the next atom on the periodic table? Helium. To make a helium atom requires 2 protons. And how many electrons? 2. We've just learnt that. 2 pluses and 2 minuses. Overall, neutral. But we have a problem, Houston. The 2 protons in the nucleus both carry the same charge. Why is this a problem? They will repel each other, so the nucleus will fly apart. This is where neutrons come in handy. Neutrons provide some extra glue to hold the nucleus together. There's an extra attractive force that belongs in the nucleus, called the strong nuclear force, that works only between nuclear particles. Without this force, the nucleus would disintegrate. Phew, again. By the way, they won't tell you about the strong nuclear force until you get to university. So this is a kind of trailer for you. A hydrogen atom doesn't need a neutron. Why? It has only one proton in its nucleus, so it won't feel any repulsive forces by nearby protons. Hydrogen is the only atom that can do this. All other atoms must have neutrons in their nucleus to keep it together. But from now on, we're going to ignore the neutrons in building our atoms to make our video easier to follow. Let's remember, though, that neutrons are found in all atoms that have more than one proton. How do we make the third atom, lithium? How about with 3 protons and 3 electrons? That's correct. But we've got another problem, Houston. Electrons live in shells that are wrapped around the nucleus, and the first shell can take only 2 electrons before it becomes full. So lithium has too many electrons to squeeze them all into the first shell. Luckily, there are plenty of shells available, so after 2 electrons fill the first shell, the extra electron can go into the next shell. This second shell is bigger than the first shell and can take up to 8 electrons. This is like a strange hotel that has only 2 beds on its first floor, so after 2 guests are booked in, extra guests have to be sent to the higher floor. The hotel's second floor has 8 beds, and so after the next 8 guests book in, this floor is also full. A lithium atom has 3 protons in its nucleus, 2 electrons in its first shell, and 1 electron in its second shell. The number of electrons in each shell is incredibly important because it affects the properties of the element and how it will behave in the world. For example, lithium is a metal because it has a single electron in its outer shell. We will explain how this happens later. The number of electrons in each shell of an atom is called its electron configuration. You should ask your parents if they know what electron configuration means. They're really cool words to learn. The electron configuration of lithium is 2 electrons in the first shell and 1 electron in the second shell. Or sometimes scientists just write 2, 1 for short. We're on a roll here. What is atom number 4, and how many protons and electrons does it have, and where do they live? Did you say beryllium, with 4 protons and 4 electrons? With all 4 protons living in its nucleus, 2 electrons in its first shell, and 2 in its second shell. If so, you can move to grade 11 in high school. Beryllium's electron configuration is 2, 2. 2 electrons in the first shell and 2 electrons in the second shell. Next atom is number 5, boron. It has 5 protons and 5 electrons. 2 electrons in its first shell and 3 electrons in its second shell. Its electron configuration is 2, 3. Then number 6, carbon. 6 protons and 6 electrons. Its electron configuration is 2, 4. Do you notice a pattern here? The number of the atom, its atomic number, is always the same as the number of protons in its nucleus. Earlier we learnt that atomic number meant the place of an atom in the list of atoms from the lightest to the heaviest. When scientists discovered these subatomic particles, they realized that atomic number was also exactly equal to the number of protons in the nucleus. It means that an atom's identity, that is, whether it is hydrogen or aluminium or gold, depends only on how many protons are in its nucleus. The atomic number of an atom is equal to the number of protons in its nucleus. We could have defined the atomic number as the number of electrons, as this is the same as the number of protons in an atom. However, electrons can sometimes be swiped off the outside shell of an atom, or an atom may grab an extra electron or 2. So this number of electrons can vary from time to time. Protons live in the nucleus, which is locked away from the outside world, and their numbers don't vary, usually. This is a better definition. Let's use up the rest of our protons and electrons. Number 7, nitrogen. 7 protons and 7 electrons. Electron configuration 2, 5. 2 electrons in the first shell and 5 in the second shell. Number 8, oxygen. 8 protons and 8 electrons. Electron configuration 2, 6. 2 electrons in the first shell and 6 in the second shell. Number 9, fluorine. 9 protons and 9 electrons. Electron configuration 2, 7. 2 electrons in the first shell and 7 in the second shell. Number 10, neon. 10 protons and 10 electrons. Electron configuration 2, 8. 2 electrons in the first shell and 8 in the second shell. Remember how many electrons that the second shell can take before it's full? 8. This means that neon's second shell is full. This has important consequences for neon and makes it an unreactive noble gas. We will explain why this happens later. Can you guess what might happen if we had another proton and electron? Where would the electron go? And what element is this? We've just built atoms of the first 10 elements on the periodic table. Each one has a different number of protons and electrons, and a different electron configuration too. As you learn more about atoms, you will discover that these elements are what they are because of these protons and electrons, and how they were put together. For example, hydrogen is an explosive gas because it has just one electron in its outer shell. And helium is an unexplosive gas because it has 2 electrons in its outer shell. And lithium is a shiny metal because it has an electron configuration of 2, 1. We will explain how this works later. Our world is as it is because of these little subatomic particles and how they are arranged. That is, because of atomic structure.